Hey guys, Jordan here from VFX Vault again, and today we're going to be going over this effect, a camera based line. So as you can see, we've got a line that goes from the bottom middle of our screen to this box here in world space. So it draws a line that's sort of attached to our camera, and as we move our camera around, you can see it moves with our camera pointing towards maybe an objective or just some kind of indicator that we can use, and we can have it pointing from any part of our screen, from the top left or the bottom right. So we'll put in the top right. Let me just demonstrate. If we, let's change it to the top left. So, sorry, top left. So yeah, you can see we can have it pointing from any part of our screen towards an objective in the world space. Okay, coming into Unreal, again we've just got our basic third person template, nothing special going on here. Then we need to come down to a new folder, just label this one tutorial, and we need to make a new Niagara system. So we go, anyone here, just directional burst, we'll call it NS, camera based line. And let's open this up. We'll bring it over to our main screen. First we can get rid of all of this. So we don't need gravity, don't need any of these forces. Don't need like velocity. Get rid of this, and let's just spawn, say, 2 particles for now. Because we're going to be using ribbons. We're going to draw a ribbon from a point on our screen to a point somewhere in the world. So let's jump down into scratch pads. So if we come down to our particle update, because we need to update the position every time the game updates, we need to update the position on our screen. So we go scratch, new scratch pad module. Then firstly we will need, because we're using the camera on our scratch pad inputs here, we will need a camera query. We'll just leave that as camera query. We'll need a position in the world. So this is going to be our, change it from particles, sorry, we need to make it to a roof pin and input, position input. So I'll call this world position input. And then we need a vector 2D, because remember we're working in screen space. So in screen space, the top left will be 0, 0, the bottom right will be 1, 1. And we go 0 to 1 from left to right, and 0 to 1 from top to bottom. So we need a vector 2 to describe that. So we go screen position. And then we have this really helpful node. So thankfully the Niagara devs have done a lot of the heavy lifting here, and they've made lots of really helpful nodes we can use so we can build this really quickly. So first things first, we go world to screen. So what this does is we can give it a world position, and it's going to spit out a screen UV. So plug that in here, and see it converts it from a position to a vector. And now it's returning a screen UV. So next, we need to have this other really helpful node called recreate camera projection. So again, you can come in and take a look at what this does. It's a bit more advanced, but it's really helpful to know what's going on if you want to start making really customizable stuff. But for now, this is more than enough for what we need. So we need the projection UV space, so projection space UV location. So this is the screen UV. So where we're coming in and explaining again, we're taking a position in the world, let's say this box. We're getting the screen space UV, the screen position. So it'd be like sort of from here to here, it'd be in the middle, 0.5, and we'll put it in the middle. 0.5, 0.5 roughly in screen UV. So we take that. Now for the FOV, this will need to change depending on what your game settings are, but in our settings now, we can set the FOV in our viewport here to 90. So we'll just go 90. Render target resolution. So render target resolution means what's our screen's resolution. So we have to come to our camera query, and we can drag off and get view properties GPU. So we're getting a bunch of properties from our camera, such as the world position, the forward vector, screen to view space, view size and inverse size. So we need the view size for our render target resolution, but as you could probably see, is it says get view properties, and if we hover over it, we get this little tooltip saying only valid for GPU particles. So what we need to do is we need to come back to our main system, and we need to change it from CPU sim to GPU sim. So that's something to keep in mind with a lot of these camera based effects. They're GPU only. So if we want to get FOV, so we've already got FOV, sorry, so it's just 90. If we want to get the view size, we could take this and there you go, it converts it automatically. So it's the view size and the inverse size. So the view size is how big is our viewport, so how wide is this across X and the Y, and the inverse size is the inverse width and height of X and Y. We don't really need to know what that does for now, so it's fine. So Z depth value. So for the Z depth value, now we've got our particle, we're putting it right on top of the camera. So wherever our camera looks, the particle is going to be placed in screen space. The problem with this is that most cameras have what's called a near clipping plane. So if there's something really, really close to the camera, it's going to start to clip it and get rid of it. So we need to have our particle on our camera, but projected down and away from the camera somewhat. So we can come over here and we can set it as a new input. We can go Z depth, and we can just plug this in here, and we'll set that input once we've finished building this. The next thing we need is the right vector, the up vector, and the forward vector. So these are the vectors for our camera. So where our camera is looking, that's our forward vector. Our right vector is out to the side, and our up vector is sort of pointing up from where we're looking. So what we can also do is get the camera properties CPU GPU. So with the camera properties, we can get the forward vector, the up vector, and the right vector. And then for the projector location, this would obviously be our camera's location. So now we can apply that. We can go set our particle's position. So here we are, set like with the particle position. We plug that in. Save that. Now if we save this, come back down, we can get rid of this. So we've got our burst instantaneous, we're bursting two particles. Let's give them a uniform size of say 10. And then coming down to our new Scratch module, we can right click and rename it to let's see, camera based line. So it's getting the player controller index, so it's getting the camera that we're using. The screen position, let's go, top left would be 0, 0 on the left side, and 0 in the 1, so we'll leave it in the top left. So world position input, for now let's go engine owner position. So wherever we put our engine owner position, it's going to put our camera based particle, and then the Z depth, we'll just give it a value of 50. So if we save this. So if we drag this into the world, what we might expect to see is that a particle will show up exactly where our system is, but you see it's offset a bit. So there can be a little bit of funkiness and jankiness with screen-based particles and screen position particles when it comes to the viewport. So you see we resize the viewport and kind of moves around a bit. Obviously it's based on the size of the viewport, and if we go say full size, still it's not exactly on top of where we would expect it to be. But if we play the game, you see it is exactly where we would expect it to be, and you can see it's on top of our character, it's on top of everything because it's set in the camera. It's just offset from the camera, so it's between where our camera is, but it's kind of projected into, it's reading the position in world space and projecting that onto our screen. Okay, so with that out of the way, next we're going to come into setting up our line. So we have our particle here, we see in the game it projects to the spot where our system is, it projects to our screen space. We'll come back, we've got our scratch pad here, and there's a few things we need to add to turn it into a line. So we're going to use a ribbon renderer, and we need a start point and an end point. So we've got our spawn count, so we've got two particles, the start point and the end point. We need to designate which particle is the start point and which particle is the end point. So we'll go new or existing parameter directly inside of our particle spawn, because we're spawning two particles at the same time, and we go make a type int, and we go modulo execution index modded by 2. So it's going to go 0 1 0 1 0 1 0 1 for every two particles that we spawn. So we could spawn say 6 and it'll go 0 1 0 1 0 1. So it's designating each pair of particles as either the start or the end point, but we're just going to have 2 for now, and we'll rename this to start / end. So you can see, so here start / end point, and then we'll come back down into our scratch pad, and if we go active overview, start / end. So now we're referencing that parameter, so we can just drag it in from our stack, active overview, and we're referencing it inside of our map get. Now we need to get the position in screen space for our starting point. So remember, our screen position is where we want the line to start. So we needed this again, we need another recreate camera projection, and we can just plug in our screen position here. So the same for the FOV, and we can have the same render target resolution, of course, the same depth, and then also here we can have the same for the camera, the forward vector, the up vector, and the right vector, and then we can just loop between both of these positions as we will have the target position as our starting position and the screen space position as our ending position, and we will plug in the start end. So remember, it's 0 for a loop, so 0 is A and 1 is B in our loop, and we just plug that into our position and we apply. So 0 0 is in the top left. So now you can see it's drawn a little ribbon, it's outlining it, but we can't see the material, so we'll fix the material just quickly. So it's got the default ribbon material here, but I like to just make my own one just for debugging. So you can just go _m ribbon, open that up, and all we need to do is just quickly, so we can see what's going on, set the base color here, and we'll just have it as a translucent or additive will do. And we'll plug in the opacity as well. So save that. That's all we need, and we can come back and just plug that in. So now our whole ribbon should be just one nice white line. So again, remember it's pointing between the offset position because we need to test it in game. So if we test, you can see now. Sorry, I'm not quite sure what causes this, but sometimes it adds another spawn burst. So you can just save that. And change our loop duration back down to 1. Again, save that. So now you can see, yes, it's looping properly and it's pointing from our top left to the target position in the world. Okay, so now we've got our line pointing from our screen space position to our world position. And keep in mind, you might need to restart the editor occasionally if the line starts pointing to sort of a weird places, or if it's pointing well away from where it should be. It might help to just restart the editor. The next thing we can do is, you see here how we've got our ribbon and it's pointing right into the middle here, but we can see the corner and we don't really want that. So what we can do is we can stretch this line out just a little bit so that it overshoots, and then this line kind of comes outside of our screen space. So I've taken our start and our end point, I've converted it into a float, and remember that the end point is our screen position and the start point is our world position. We can just stretch it out by using a loop, and we can go 1 point, say 1, 2. So now it's taking our 0 to 1, changing it from 0 to 1, 0 to 1.2, and then we plug that into our loop for our position. We save that, and now you can see we're not seeing that corner unless it's at a really tight angle, but even then it's fine. So we're stretching past the edge of our screen space now. Next thing we want to do is, this last thing that we want to fix is this. When it moves outside of the screen space, it kind of just pops to the top right because our world position is no longer in screen space, so it's just returning 0, 0. So you can see it's just pointing from the top left to the bottom middle. We can map that range so that it fades out as it moves towards the corners. So what we can do is we can get this position here. So it's a little bit untidy. Let me just tidy this up. So we have this top one, and we'll comment that as screen space position, and then we'll comment this bottom one as world position in screen space, or target position. And then we can get the color. So we can get whatever color we have here. So we'll go, this is our particle color, whatever color we're using. And we'll just drag it out here and go break. So we're breaking it out, our linear color. And we'll go make linear color. So we have our linear color. Plug them in, plug it in, and it's just the alpha now that we need to map as well across our screen space. Okay, so I've just copied this this node here, the world position to screen position, up here just for clarity, just to keep it nice and easy. So we can multiply by 2. So from now, instead of going from 0 in the top left to 1 in the bottom right, it goes from 0 to 2. So go float, and we go float multiply by 2, and then we go subtract by, again, 1. So we're subtracting by 1. So now we have -1 in the top left to +1 in the bottom right. And then if we go absolute, so now we have 1 in the bottom left, so sorry, 1 in the top left, 0 in the middle, and 1 in the bottom right. So it goes 1 0 1 as we move across our screen, and then we 1 minus. So now we're inverting that value, so it goes 0 and now 1 in the middle and 0. So maybe you can see what we're making. And then if we multiply, and we'll put in another one last thing here, float, one more float input, and we call this edge fade hardness. Again, this is just a simple, really quick, dirty way to do it. There's probably much nicer ways that we can do it. And we will plug this, or we will multiply this against our particles alpha. So we apply, save that, and then we enable our particle color. So remember, we've got our alpha that's reading from this curve over time, but we can multiply that value that it's outputting from our curve. We're multiplying it here against the values that we're setting with our sort of edge fading here. So if we save that, and we come back into the world. So it's not quite working. Let me see exactly why it's not quite working. So we of course, because we haven't set the input. So let's just set it to 1 for now. We save that. And then as we move towards the edge of the screen, you see it fades off. Now we can set the hardness. So depending on sort of how hard we want it to be, how close to the edge we want the fade, we can go like say 10. So as we move really close to the edge, and then it kind of just really quickly disappears at the last second. But the good thing, the important thing now is that it's not sort of snapping to the top left corner like it would be if we didn't have that fade at all. So you can see now as it moves to the edge of the screen, it fades away. So I hope this was helpful. If you've got any questions, let me know. Remember, there's a few sort of tricky little gotchas with this workflow. If you're seeing issues with the camera space stuff, be sure to maybe just reopen Unreal or double check that you've set everything up in the scratchpad properly, or check it in game. It tends to work reasonably nicely when we check it in game. And there's one last thing actually that I will quickly show. Is you see when we move our screen around, it's quite blurry on the bottom of the ribbon there, because that comes from the motion vectors. So there's two quick ways to fix that. Just quickly, so we can disable the motion vector setting here. So we save that. It's a little bit better maybe. And then the other quick way is if we come into our ribbon material and we type after, we just want to set the translucency pass to after motion blur, so it's not motion blurring our particles anymore. So see, now it's perfect. It's nice, not blurring if we move the camera really fast. So that's it. Again, if you have any questions, if you have any comments, let me know. I'll put the Discord link below where I upload a copy of this effect with the scratch pad, so you can just make sure that you've got it right. If you've got any questions, feel free to ask in there. If you've got anything else you'd really like to see, let me know, and I'll probably continue to build on this one because I really like doing screen effects, and camera-based effects can be really cool. But yeah, this has been Jordan from VFX Vault, and thanks for watching.